Sum series and integral calculus. Sum series and integral calculus in which we are making the discussion. Sum series and integral calculus. Can I calculate the summation of Fibonacci series through integral calculus? It would look weird. It would look weird that can we really calculate the summation of series through integral calculus? You are amazing. You are awesome. Means you can do everything possible in the world as far as addition is concerned. After all, integral calculus is a expansion. It is an advanced shape of multiplication only, and multiplication is an advanced shape of addition only. Means addition can be done through can be achieved through multiplication, and then multiplication can be achieved through integral calculus. Addition to multiplication, multiplication to integral calculus. Integral calculus, it is same as multiplication only. There is no difference between integral calculus and multiplication. There is no difference at all. Okay, multiplication is area multiplication of two items is area of a rectangle where the operand of multiplication has two operand and one operator. So two operand of multiplication are two sides of rectangle, and then calculating the area of rectangle is the multiplication. Okay, now is I mean, if someone is doing multiplication of two items A into B, multiplication is operator and A and B and A are operand. These two operand are side of a rectangle. Then someone can calculate area of a rectangle, and that is the multiplication. If I proceed more on this in calculation of area, to calculate the multiplication, then if I have a shape where one side is flat but another side is up, I would rather say I have a shape where three sides are at 90 degree to each other. I have a flat side, flat side, but top side is a function rather than flat side. If all four are cutting each other at 90 degree, then calculation of area is nothing but take any two side at 90 degree and calculate the multiplication. Means multiplication is nothing but area of a rectangle that is formed when the two operand of multiplication are two sides of the rectangle. Same. Okay, if the two side of if it is not the same, then that is the question. Okay, then people started thinking about it. What I'm trying to say is this is one side, this is one side, this is one side, this is one side, and another top side is also flat, 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 vertical, vertical. If this is A and this is B, calculation multiplication of B into A is same as calculation of the area. Okay, or multiplication of, if this is B and this is A, then this is B and this is A, because this top and bottom are same. This into this will give the area. Means if I can draw a rectangle with the two operand, one as this and another as this, then it will calculate the area. Okay, that is the multiplication. If top is not flat and it is a some function of x, then multiplication will, then we cannot calculate multiplication to have the area. Multiplication will not give the area. Rather, area will give the multiplication. What do you mean? Means I am trying to say if I am doing 5 into x, 5 into x, where this height is 5 and this side is x. Makes sense? This is x. X into 5 will give area of a rectangle whose one side is 5 from here to here. Sorry, here to here x and here to here 5. 5 into x. What about instead of vertical as 5? This is a a kind of matter of debate. Okay, when I take x as origin, I have a vertical 5. At every variable x, I have vertical of 5 only. If everywhere vertical is 5, then 5 into x will give the area of this rectangle, or area of this rectangle, if someone calculate, it will be exactly same as height into width. Make sense? Consider this height is not same. Here x equal to 0, height is different, x equal to 1, height is different, x equal to 2, height is different, x equal to 3, height is different, x equal to 4, height is different. Okay, in that manner, if everywhere height is different, then how we can calculate the multiplication where height is different. Okay, if height is everywhere same, then height by width, I can calculate multiplication. Height by width, I can calculate the multiplication and say this is the area. But if height is varying at each places, then what is the multiplication we calculate? Yeah, we can still calculate the multiplication. Considering this height is dependent upon x, if x is varying, then height is also varying with the x. I can say height is a function over x. Rather than saying 5 into x, I can rewrite as function over x into x, where function over x is changing as the x is changing. What is function over x into x? Function over x into x, what do you mean? Because function over x is changing with the x. It is not a constant. Okay, but I want function over x into x. Or do you want area? Yeah, I want area. because because multiplication of two item is area of a rectangle. Okay, if area is not a rectangle, then multiplying the two item is abstract multiplication. It is not a straightforward multiplication. If I multiply 5 into x, this will give area of a rectangle whose one side is 5, another side is x. But if I say it is fx into x, then one side is fx, that is the height, which is varying, and one side is x. This will give the pseudo multiplication. Function over x into x is pseudo multiplication. But what is concrete then? Concrete is area. Area is concrete. Someone can tell what is function over x. Consider this is sin x, then this is sin x, where this is x equal to 0 and x equal to 5, and this is sin x. This is sin x, and this is the area of sin x, fx dx. Fx dx. Up. This equation of this curve is sin x. Okay, I can say sin x into x, means I'm trying to say that you have to calculate vertical by horizontal, but vertical is varying. So I can rewrite as function over x into x. That is the multiplication, but this is not a concrete multiplication. Function over x would vary with the x. If function over x was 5, then 5 into x, I can say multiplication is 5x, where you can keep on changing x, no problem. But if it is sin x into x, then this multiplication is a pseudo multiplication, abstract, not real. What is real is the area. Someone can compute the area and he can say this is your multiplication. Multiplication is abstract, but area is concrete. Area calculation, getting multiplication through area, is called integral calculus. This is many times we have talked. Means not every integral calculus is, I'm sorry, not every not every integral calculus is multiplication, but every multiplication is integral calculus. Any multiplication, 3 into 4 can be brought into integral calculus. 3 into x can be brought into integral calculus. Sin x into x can be brought into integral calculus. Sin x into x will become sin x dx from lower limit to higher limit. But all integral calculus cannot be brought into multiplication. Sin x into x, it cannot be written in multiplication. No one can multiply sin x with x, not possible. But someone can calculate this through integral calculus, because integral calculus talks about calculating the area. And if you consider that is your multiplication, this is your favor. That's it. So if I try to calculate multiplication through area way, then non-linear equations also I can calculate the multiplication. That is the concept. Anyway, now the concept that is going on, we will see there are many use of integral calculus. Integral calculus can calculate the Bayesian theorem in probability very nicely. What is Bayesian theorem? Bayesian theorem talk about conditional probability. Conditional probability. Conditional area, integral calculus, if I move along x-axis, then conditional multiplication. Multiplication means multiplication of height with the width on condition that height will change with the x. If height is not changing with the x, then height is constant. Then this area can be calculated through normal multiplication. If height is not constant, then this area cannot be calculated through multiplication. This is the better way I can say. If the height is varying with the x, then this area, underneath this area, cannot be calculated through multiplication, not possible. But if its height is constant with the x, then this area can be calculated through normal multiplication, width into height, because height at every x is constant. But if height is varying with the x, then this area cannot be calculated with the multiplication. Area is superset and multiplication is subset. Okay, in superset for only rectangle multiplication works. Otherwise, for other, then you have to go through integral calculus. Okay, anyway, means integral calculus is superset of multiplication. Multiplication is not superset of addition. All addition cannot come to multiplication, but all multiplication can be represented through addition. Possible. 3 into 4 can be written as 3 plus 3 plus 3 plus 3. But 1 plus 2 plus 3 plus 4 cannot be written in multiplication. Okay. 1, 2 plus 2 plus 2 can be written as 2 into 3. Not all addition are multiplication. Not all area are multiplication. Multiplication is little construct, but whatsoever. Area is superset of multiplication and addition is superset of multiplication. This is the relationship. Anyway, we will see Bayesian theorem and those kind of thing also, where things are calculated through conditional way. Conditional way, like 10% of people in around the world they talk in German language. Consider in that manner. 10% of people in the world they talk in German language. And in Switzerland population is 5% of the world population. Consider in that. Switzerland population is 5% population in the world. And among Switzerland, 30% people they talk in German. Okay, then if I ask what is the percentage of German speaking German speaking Swiss people among the German speaking around the globe? That is the question. Now someone would ask, what is the probability of German speaking people around the globe? This is one question. German speaking people around in Switzerland, what is their proportion if I see all people around the globe? Then Switzerland people are 5% of the total population. Then 5 by 100 is Swiss people only. And then in 30% German speaking into 30 by 3 by 10, 5 by 100 into 3 by 10, that will come as 15 by 1000. 15 by 1000 means 15 people out of every 1000 people around the globe, they are German speaking Swiss, means they speak German and they are Switzerland citizens. This is one question. Another question is, consider 10% of, means 1 in 10 people around the globe, they talk in German language. Then what is the conditional probability? Probability means proportion only. Probability means proportion only. It is a fancy word called probability. This work has probability of 2%, means out of 100, 2 is chance of happening. What is the probability of a rain? What is the probability of rain Today, what is the probability of rain? 10%. What do you mean by 10%? 10%, you said 10%. Today, 10% is the probability that it will rain. Okay, someone can think that within 24 hours, it may rain for 10 by 10% means 10 by 24 hours. Someone can take in this manner also. There is a 10% chance of rain today. 10% chance. What is 10%? Someone would ask, what do you mean by 10% chance? Out of 100, 10 is a chance of rain. What is 10%? That you have to tell me. What is 10%? Okay, can I consider in time means out of 24 hours, 2.4 hour it will rain? That has to be asked because probability is nothing but proportion only. If I said 10% people are German speaking in the world, means out of all the people in the world, every one person in 10% they speak German. That is proportion only. Okay, if I say German speaking people in Swiss are 0.015%, means out of 1000 people in the world, 15 people speak German and they are from Switzerland. Now question is, if there is a Swiss person who speaks German, then out of all German speaking person, what is the percentage? This is the conditional probability. On condition that 100 people are speaking German. Consider 100 people are speaking German. Among them, how many are speaking German and they are living in Switzerland? That is the question. Straightforward. Okay, in Switzerland, 30% people they talk in German, and Swiss people they are 5% of the world. 10% of the world population they talk in German. Out of all German speaking person, what is the probability that he will be Swiss German? Okay, then the straightforward is first find out what is the population of German speaking person and then find out what is the population of German speaking person in Switzerland. Makes sense? Total population. Okay, then I would say I don't know the total population, but total worldwide population I know. Okay, tell me that one. Then it is 0.015 is the worldwide population percent. 0.015. 0.015. Oh, I think so. No, 5%, 5 by 100 into 30 by 100. 3 by 10, 5 by 100. Yeah, it will come like that only. Okay, again wrong. 15 by 1000, how much percent will be multiplied by, oh, 15 by 1000. Okay, how much it will come? 0.015 into 100. 1.5, that is 1.5% of total population speak in German and they are Switzerland citizen, whatever. And 10% of people around the globe they speak in just German. They may be German citizen, they may be Italy citizen, they may be other country citizen. All total, what is the probability that out of all German speaking person he is Swiss German? Then 1.5 by 10. What is the probability that a person is a Swiss German around the globe? Then it is 1.5%. Every 100% you take, then out of that 1.5%, or I can say every 200% you take, then 3% will be German speaking from Switzerland. Okay, if I say that out of 100, every 10 speak in German around the globe, then among German speaking, how many people they are from the Switzerland? Then it is 1.5% by 10%. That will come as 1.5% by 10%. 1.5% by 10% means this is the conditional probability of people who are, how much it will come out of all people. 10% are, I think it should be more. 1.5% means out of 100 people around the globe, about 100 people around the globe, 1.5 people are from Switzerland. If I change the sample space, bottom is 100, then 1.5 is a numerator, that is a German speaking Swiss person. If bottom 100 to 10 if I make, then how I can make? Then both sides I have to multiply by 10. Then it will come as 15. Means 15%, 15% out of 100 German speaking person is in Switzerland. Makes sense? Okay, this is called conditional probability. Means out of every 100 German speaking person, out of every 100 German speaking person, 15 live in Switzerland. Okay, how to measure it? Then someone can try. Conditional probability denominator is the German speaking percentage, that is 10%. Makes sense? Now 10%. Top is how many percent is Swiss people? 5%. 5 into, in that how many people are German? Then 5 into point 0.3, 30%, 0.3. 5 into 0.3 by 10. That will come as 1.5 by 10. That will come as 0.15 in percentage. 0.15 into 100. It will come as 15%. 15% is the conditional probability of German speaking Swiss out of all German speaking person. Every 100 German speaking person, 15% live in Switzerland. Otherwise, it is 1.5%. Out of all 100 people living in the world, 1.5 is the German speaking Swiss out of all 100 speaking. This is the simplest example I have given of the bias theorem. We will talk much more on it, where we will see integral calculus. Integral calculus, now we will start talking about the distribution of German people, distribution of Switzerland people, distribution of German in Switzerland as a function over x and y, as a function over x and y, where x can be people who represent German speaking, where y can be people who live in Switzerland and they are orthogonal to each other. X axis where people live in Germany, they are German speaking, and y axis people live in Switzerland, they are orthogonal to each other. Why they are orthogonal to each other? Because if there are n number of people, they can be distributed in language manner. If there are n number of people in the world, they can be distributed in country manner. Switzerland falls in country manner. Distribution of people in country manner is called Switzerland. Distribution of people in language manner is called German. They are at 90 degrees to each other because they are not related to each other. If I have 10% of people, if I have 10% of people that talk in German language, the rest of the people who talk in other language are 90%. If I say rest of the people who do not talk in German language, they are 99%. Then German language speaking person is 1%. Means they are settling down each other. They are occupying. They are linear. This is called collinear. If I increase German language people, then other language people speaking will become less. If other language people speaking is more, then German language will become less. Means changing in one is changing other. This is called collinearity. So they will be along same axis. Means all the language. This is German speaking, then this is non-German speaking. They are on the same axis because changing one will change other. This is called, they are at 0 degree with each other. They are on the same axis. Now let's talk about another axis called country axis. And in country axis we have Switzerland. Doesn't matter. Your German speaking is increasing or other language is increasing, they will settle down along the x axis only. Where y axis is completely different. If I say out of n number of people, in n number of people, 100% people they talk in non-German manner, but doesn't matter. In Switzerland, it may not matter. Okay, minutely it will matter, but it may not matter. Consider there is a country which does not have any German speaking at all. Then size will not change. Means more or less they are orthogonal to each other. where if I say I have a country called Switzerland where people are 5% and rest of the world people are 95%. If rest of the world people are increasing, where net number of people are not increasing, this means the Switzerland people are decreasing. They are collinear to each other. Means one axis I can divide it country wise and one axis I can divide by language wise. Okay, then whatever the graph I am drawing, this is called fxy. Fxy. What do you mean by fxy? Fxy means I have 3D shape. Now, this is x-axis, this is y-axis. Now, if I take any coordinate here as a language coordinate, consider this language is Sanskrit. And here I take any coordinate as country coordinate. That country coordinate is India. Then I take this point as x comma y, where x is Sanskrit and y is India. Then I take a vertical. This is xy plane. I take vertical and then I see what is the vertical value. What do you mean? That vertical will say that intersection of Sanskrit and India, how many people are there? Okay, many ways we can draw this diagram, and then many ways we can calculate the conditional probability. This is called function over fx, function over x and y gives the another thing. What about integrating function over x and y over x? What is integrating function over y along y? What is integrating function over y xy along dx dy? This will talk conditional probability through integral calculus. Makes sense? Depends upon how the things are distributed. Simplest numerical conditional probability we talked, and that was numerical, German percentage and this. But it can be in algebraic manner. Same thing. If I'm trying to calculate area of a rectangle, then both sides can be numerical. We can calculate simple multiplication. But if the side of one side of rectangle is not a constant vertical, it is in function of something, then we need same thing. We are trying multiplication, but multiplication where once one operand becomes function over another operand, then we need integral calculus. The way same way we will do in Bayes theorem also. If things are pretty straightforward, it is 10%, that is 20%, that is 30%, that is 40%, then we can calculate the conditional probability normally through multiplication and division. But if distribution start happening over x-axis and y-axis differently at different x and y, then we will do same multiplication and division through integral calculus. I believe it is understood now that numerical multiplication is multiplication, but algebraic multiplication where one is dependent upon another, that comes in integral calculus. Anything, what Bayes theorem, anything, either it is a bank problem, any problem. If this kind of thing starts happening, then we use integral calculus. Anyway, we are in discussion of calculating the 1 plus 2 plus 3 plus 4 plus 5. This is what we have talked. What is 1 plus 2 plus 3 plus 4 plus 5? Can someone calculate 1 plus 2 plus 3 plus 4 plus 5? Okay, it is not difficult. 1 plus 2 plus 3 plus 4 plus 5, we have already talked about, it is n into n plus 1 by 2. Means if I say 1 plus 2 plus 3 plus 4 plus 5 plus n, means there are n number of terms, then it is n into n plus 1 by 2. Now question is arising, think in that manner. If question is arising in examination, what is 1 plus 2 plus 3 plus 4 plus 5 up to n term, how much it is? Then someone can write n into n plus 1 by 2. Alright. But consider that in examination it is written 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to 51. You tell me. Now you are free to use any fundamental. 1 plus 2 plus 3 up to 51. Someone is free to use any formula. And one of the formula that we are talking is, consider this is x-axis and this is x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In that manner, if this is x, then I have a function over x and that is the vertical. If x equal to 2, then I have a function over x that is the vertical. If x equal to 3, I have a function over x that is the vertical. What is the function then? Function is 2x minus 1. When x equal to 1, vertical is 1. When x equal to 2, the vertical is 3. When x equal to 3, then vertical is 5. But this is called sampling x-axis at x equal to 1, 2, 3, 4, 5, 6. For a function 2x minus 1, can I sample the function 2x minus 1 not at x equal to 1, 2, 3, 4. Sampling it at x equal to 1, 1 and a half, 2, 2 and a half, 3, 3 and a half, 4, 4 and a half, 5, 5 and a half, like that. Okay, if I sample in that manner at half space, half space, can I sample this at half space? Can I sample it? Yeah, we can try now. If I sample at x equal to 1, 2x minus will give vertical 1. If I sample at x and 1 and a half, then it will give vertical, it will give a vertical as 1. It will give vertical here at 1 and a half will be 2. At 2, vertical will be 3. At 2 and a half, vertical will be 4. Means if I sample x-axis at half, 1, 1 and a half, 2, 2 and a half, 3, 3 and a half, 4, like this, then vertical at those locations will be 1, 2, 3, 4, 5, 6. Can I calculate this? This is what we are doing. One way we have already done in the past video. Okay, this is called through successive approximation. This can also be considered as discrete to continuous function changing, because integral calculus works in continuous function only, not in discrete function. This is a discrete function 2x minus 1 at x equal to 1, 1 and a half, 2, 2 and a half, 3, 3 and a half, like so, where vertical is 1, 2, 3, 4. But I am interested in adding all the vertical. But vertical will appear not at any x, only x that is at half distance. If I connect all the top point, then it will become a line, and that is 2x minus 1. Then it will become a line that is 2x minus 1. Okay, now this is called fx. 2x minus 1 is the fx. Can I bring another function gx? Another function gx, for which every between two sub area will go and hit gx. Sub area between x and x equal to 1 and 1 and a half will go and hit gx. Between 1 and a half and 2, it will hit gx, and each sub area is same as vertical on right hand side. This side we have vertical on left hand side. I'm sorry. This is x equal to 1. Can I think about the area between half and 1? Sub area between x equal to half and x equal to 1. This sub area will go another function called gx, that is a continuous function, and this sub area will be same as right hand side vertical. What I am trying to say is, if I take any x equal to x, then vertical here is 2x minus 1. Then I am talking about a sub area from x minus 1 by 2, to x, and that will go hit gx. I am trying to say fx equal to x minus 1 by 2 x gx dx. If it holds true, then all the verticals what I need to add, all the vertical can be described through different sub areas, where first sub area will go half to 1, second sub area will go 1 to 1 and a half, third area will go 1 and a half to 2, like so. So first sub area, second sub area, all sub area will be same as number of vertical. All the sub area will be same as number of vertical. If I take one particular sub area from x minus 1 to x, that will match the vertical at fx equal to x. And if I am able to bring gx in that manner, I can solve it. Okay, in previous video we tried right hand side, x to x plus 1, x to x plus half. This time we are trying x minus half to x. Okay, in that manner we will do fx equal to limit x minus half to x gx dx. Okay, fx is 2x minus 1, gx dx, x minus half to x. What is gx? If I say fx equal to gx dx, gx equal to dfx by dx, that will be 2. 2x minus 1 differentiation will be 2. Okay, if it 2, will start with the 2. 2 dx integration is x minus half to x minus x plus 1 by 2. It will come as 1 by 2. It will come as 1 by 2. Okay. But we want 2x minus 1. Answer is 1 by 2. Means to get 2x minus 1 from 1 by 2, I have to multiply with 4x. Leave the right hand side minus 1. Just settle down the first order. 2x will 2x is the target and we are getting 1 by 2 means I have to multiply with 4x. So we started with I think so x minus 1 by 2 to x, and then we started with 2 dx 2x from x minus 1 to x, then it will become 2 1 by 2, it will become 1. I have to multiply with 2x, not 4x. So now we will start with the 4x. 2 was earlier, I have to multiply with 2x. 4x, we will start with 4x. 4x integration will be 2x square. 2x square, 2 I can keep outside, x square, x minus 1 by 2 to x. Okay, in that manner, x square will become x square minus x square minus, and in bracket x minus 1 by 2 whole square. In that manner, it will become x square minus x square minus 1 by 4 plus x. 1 by 2 into x into 2 will be x only. Means x square minus x square will go up, and then it will become x minus 1 by 4. Outside 2 is waiting. 2x minus 1 by 2. This is what I think. 2x minus 1 by 2. Target is 2x minus 1, but we are getting 2x minus 1 by 2. Means I have to add 1 by 2. 3 by 2. I have to add 3, I'm sorry, I have to add 1 minus 1 by 2. If I am getting minus 1 by 2, I have to add minus 1 by 2 or subtract minus 1 by 2 to get 1. So we'll try again. 4x minus 1 by 2. Now 4x minus 1 by 2, from x minus 1 by 2 to x. We'll try again. 4x, x minus 4x will become x 2x square minus 1 by 2x. 2x square, 2x square will be settled down as x minus 1 by 2. This is what we have already seen. X minus 1 by 2 minus 1 by 2 x, x x x will become x minus 1 by 2. That will come as 1 by 2. 1 by 2. Outside minus 1 by 2 is waiting. Minus 1 by 2 into 1 by 2. Minus 1 by 4. This is what I don't want. I wanted more 1 by 2, not 1 by 4. This means that I have to start with, we did, we, hop. Okay, okay, we started with 4x minus 1 by 2. We'll try 4x minus 1. 4x minus 1. We'll try. This is successive approximation. 4x minus 1. We'll try again. 4x, 2x square minus x. 2x square will become x minus 1 by 2. This is already we have seen. Minus x minus, and x will become 1 by 2 minus 1 by 2. Now it is same. 2x minus 1 by 2 minus 1 by 2. 2x minus 1. Both are same. Means gx is possible. If I take gx as 4x minus 1, gx as 4x minus 1, then it's the sub area, the xth sub area. If I have x equal to x, then I have a vertical at 2x minus 1. And if I take left hand side area from x minus 1 by 2 to x, the sub area is same as this. I have found the gx, that is 4x minus 1. Can I calculate the addition of all the vertical as same as area from 1 by 2 to n, where n is not the number of vertical. N means x equal to 1, 2, 3, 4. That is the n. Okay, we'll try now. The net addition will be 1 by 2 to n. 4x minus 1. 4x integration will be 2x square minus x. 2x square minus x. 2n square minus n. Keep it. And then minus. And in bracket, I have to settle down 2x square minus x with 1 by 2. 2x square, 2x square, 2x square, means 2 into 1 by 2 whole square. That will come as 1 by 2 only. 1 by 2, 1 by 2 minus 1 by 2 minus, okay, x is 1, x is 1, oh, gone. 2n square, that is 2 into 1 by 4, 1 by 2 minus n, n is 1, gone, 0, nothing will be there. So net result is 2n square minus n. If people remember last video, we got through right hand side at 2n square minus n only. Both are exactly same. Means solution to this problem, 1 plus 2 plus 3 plus 4 plus 5 plus up to 51 is 2n square minus n. Then tell me, what is 51? What is n for 51? For n for 51, I have to say 2n or 2n minus 1, 2x minus 1, 2n minus 1 equal to 51, 2n equal to 52, n equal to 26. 26. So here n will be 26. Now he can quickly find out 226 whole square minus 26. 226 whole square minus 26. Okay, that's it. 226 whole square minus 26 will give the result. Okay, that will be 26 outside, 2 into 26 minus 1. 2 into 26 minus 1. 26 into 26 into 51. 26 into 51. Actual result is n into n plus 1 by 2, where n is 51. 51 into 52 by 2. 51 into 26. Same thing. The reason we are bringing this discussion to make people understand that how to put limit. Limit is important in this approach because this approach is generic. More we will talk. I'll try the middle one. If fx is in middle, then I have to take limit from point 0.25 left side and 0.25 right side. 1 by 4, 1 by 4. Someone can try. 2x minus 1 should be equal to limit x minus 1 by 4 to x plus 1 by 4 gx dx. Then someone has to find gx dx, and then at the end he has to try gx dx from 1 minus 1 by 4. It will start from there. 1 minus 1 by 4 to n plus 1 by 4, and it should come same at 2n square minus n. This can be taken as an assignment. Mind blowing, amazing. All the solution through a same way of integral calculus. Someone can compute the Fibonacci series to any series, the summation. Amazing, mind blowing. Okay, we will see this kind of thing in Bayes' theorem and those were also. Okay, why to calculate so hitting head? What I am trying now. If someone understands this generic way, then someone can crack some generic way of finding algorithm which would work for all kind of data. That is the target. Anyway, please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the country code, 9483160610 is the telephone.